Okay, hi everyone. Thank you so much for joining my talk. And this talk will be about Terraform practices. And Terraform is a great tool, right? It is used widely across the world. And this talk will show you not only bits and pieces regarding Terraform usage and practices, but also, hopefully, will make you think about using Terraform in a broader context rather than just an infrastructure as code tool. So very little about myself. As I was presented, senior DevOps engineer. I have 15 years of experience in the tech industry. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And I'm also, since I talk about Terraform quite a lot, I got to be a HashiCorp ambassador because of that. And basically, I really like to mentor in courses and communities and share knowledge as much as possible. And on my spare time, I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so Terraform implementations can be good, can be bad, and sometimes can also be ugly, and we will cover those things. Two disclaimers. First of all, the examples that I'm going to show here are mostly from the AWS provider, but of course, Terraform works with all providers out there, all cloud providers, GCP, Azure, etc. And I haven't used Terraform Cloud or Enterprise. The only thing that I'm going to share here are practices from Terraform open source. And speaking about open source, we can't at least mention the license change that Terraform had. So basically, HashiCorp changed the license from MPL v2 open source to a business license, which is source available. This is how it's called. And this emerged the OpenTF that just recently they changed the name to OpenTofu. I don't know why. I didn't have the time to read any articles about that. But the thing about it is that I can share my take on it. If you don't really compete with HashiCorp, there isn't much worry about that. But some other people, the people that created OpenTF, Tofu, they think that since it is now business license, it means that from a community-driven tool, it will become a business-driven, so the roadmap will gonna change and stuff like that. We need to see how it goes, but the fact that it got OpenTofu got adopted by Linux Foundation means something. So we just need to see how it goes. But it doesn't matter. The practices I'm gonna share here applies to both OpenTofu. It really is weird to say that, OpenTofu. Like, I'm vegan and still, I don't know. So the practices I'm going to share here are for OpenTofu and also for HashiCorp Terraform, because it's about Terraform as a tool. So let's get right to it. So first of all, I'm going to start with quick wins. Quick wins basically are things that you can achieve in a matter of minutes to utilize Terraform better. Low effort, high value things that will help you scale better and more efficiently and prevent refactoring and extra work later on. So first of all, versions lock, same as you lock versions for Python in requirements txt or packages.json lock, same goes for Terraform. You can lock versions for modules, providers, and Terraform itself. This is how you do it. And the thing about locking providers' versions and why is it so necessary is because of this meme that was created by Anton Babenko. If you don't know him, please follow him. He's like a Terraform celeb. He's the main maintainer of Terraform AWS modules that we all use. So as you can see, we want to manage everything as code, and then sometimes Terraform AWS provider issues get in the way. So locking provider issues versions means dealing with the versions and dealing with the devil that we know. Otherwise, we could potentially have syntax stuff that we didn't expect, any other issues that we don't know about just because we didn't lock the versions, and now we need to deal with other versions that we don't really know. So lock providers' versions and at least deal with the devil that you know. So the good thing about versions lock, you should really lock modules, providers, and Terraform versions. The bad thing is lock in a way that will still allow breaking changes to occur, because if you lock to a minor version, some breaking changes can still slip through. And the ugly thing is to have no versions lock whatsoever. Trust me, you will have syntax issues. You have, hey, we don't support this anymore. And then you'll need to refactor things on the run and don't really get an opportunity to prepare for that. So try to avoid that and always lock your versions. Next up on the quick win section, tagging resources. So tagging resources in the cloud era is very, very good because that way you're able to filter your cloud provider expenses and sort them by tags to distinguish between resources. You have also ability to cost control if you use any other external tools like Datadog. They allow you to use cost control, and it is done through tags. It also allows you to gain visibility on ownership and overall project by tagging according to a logical breakdown. So tagging is very, very important. And really, if you tag your resources, your FinOps team will be very, very happy. And if you don't have a FinOps team, congratulations, you are the FinOps team. So that's exactly it. So these are the tags that we use in Wix. And a good thing about Terraform is that, at least in AWS Provider, you have the ability to have default tags, meaning any tags that you set in this level will be inherited to all resources that get created in AWS. So you need to use it as you see fit. Of course, the classic usage is managed by Terraform, and then all resources that got created by Terraform will automatically get this tag. But anything that comes to mind that you see fit for your company or your department, you can set it here, and then it will get inherited to all AWS resources. So the good thing is to tag everything that you can, really. Don't skip anything. Everything is good. Use default tags to your best ability. And another good thing that we will cover in the last section of this presentation is PR enforcement, meaning doing some tests and checks to make sure any practices are being applied. In this case, it means that if, for example, a developer or a DevOps engineer introduced some changes in Terraform code or new resources, and these resources don't have tags, then the PR will fail to merge because there are no tags. But we will cover practices enforcement in the last section of this presentation. Bad thing, tag inconsistently, because as we know, consistency is key. It's very easy to track things if we have consistency, and if not, it really is hard to then see where are our missing pieces. And the ugly thing, no tagging whatsoever, not great. Please try to avoid that. Last thing in the quick win section, remote state. So by default, Terraform work with local state, which is good if you need to do some stuff locally or you are on your own at home, not even in a workplace, but because I really, really urge you, even if you are the sole maintainer of Terraform in your company, still utilize remote state, because that way you can make sure it is backed up through, for example, S3 versioning, it is secured, and it has much more best practices to it than using Terraform state locally. So this is a way how to do it in AWS, but again, of course, it works with GCS as well, so you can set it up. So remote state for the win. You have one source of truth, and then whenever you need to scale other teams, etc., then they can all use the same state, and it's also a good practice to have. So the good thing, make sure that your state is remote and secured, make sure it is backed up through S3 versioning, for example, and make sure that the Terraform state gets locked whenever you run Terraform apply, so you can utilize DynamoDB for that. Because why do we need that? If two people try to run Terraform apply on the same state, then it will get locked and say, hey, someone else is running it, please wait. And this way, it would assure that there's no collisions or no state corruptions, which is very, very important. The bad thing and the ugly are pretty much the opposite. So if you have local state, if the state is remote, but you're not making sure that it is secured or backed up, and if the state is not getting locked, then it's also not good. I also gonna mention later on a usage that we do of open source tool called Atlantis, which takes care of it for us, but I will touch a bit on it a bit later. Next section, second nature. Second nature basically means things that you should have in your back of your mind, not back, somewhat forward, when working with Terraform on your day-to-day, so things to consider while working on it day-to-day. That will help you, again, reduce refactoring, in the long run, prevent time waste, and align to best practices. So first of all, using community modules versus creating the modules yourself. So there are a lot of modules out there, for example, Terraform AWS modules that already provide the functionality that you need for creating S3 buckets or anything of this sort. So there's a phrase, why reinvent the wheel, right? If there are already community modules that provide the use case that you need, it's better to utilize them because they are proved over time. They are supported by the community, and you eliminate the need to support it and keep it up to date because there are other maintainers that do it for you. And also, community modules follow the practices enforcement that I'm going to share in the last section of making sure the code in the modules are in a high quality state. There are checks and tests that are being done on the modules on each PR that's being introduced, and I'm going to share a screenshot later on. So the good thing, use verified community modules where possible. What does it mean verified? Up until recently, there was the name was signed community modules, but HashiCorp removed the ability to have a signed community module, and they just say it's verified. So they don't allow that bulletproof signing anymore. So just it means that whenever you want to use community modules, check the number of downloads of that module. If there are millions, probably it's a good module to use, and it is safe, security-wise, etc. The bad thing is to create a module of your own while a community module already exists, but if you still maintain it as such, if you have a test in place and make sure that there are checks and consistency and whatnot, then it's still quite okay. And another bad thing is to have a community module usage without version lock, because as I mentioned before, you could potentially have issues with it going forward. And the ugly thing is to have both custom and unmaintained modules that you create, because then it will get out of hand very, very quickly. People wouldn't know, can I use it, can I not use it? Maybe it only fits certain use case and not. So it's not good to have. And if you use unverified community modules, it could potentially introduce malicious configuration to your environment, which is not good. So make sure you pay note to that. And if you do have to create your own modules, make sure you make them stateless and clean as much as possible, aka make them generic, aligned to do not repeat yourself, and keep it simple, stupid principles and other clean code practices. And make sure that you introduce enforcements to maintain quality of this code. And again, I'm going to touch on that section later. Next up, variables versus locals. So unlike variable values, local values can use dynamic expressions and resources arguments. And locals also don't change values between runs. When you run Terraform plan, apply, destroy, it always keep the same value, which is good. And I'm going to share with you examples how. And you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. So if we take this example, for example, we have variable project name, variable environment, and then the locals basically do a merge between those variables and other required tags for the environment, etc. And then whenever someone uses tags, they always get this final definition, and it gets applied throughout the entire usage. And it's good because you don't need to think about it. You just define it once and then run with it. So on module side, the purpose of variables is basically to have settings for the module configuration, but also make sure that you set default and validation on the module side, because if not, and someone would use this module, then the module will get break because they didn't provide value for that variable. So make sure that for every variable, you set either default or validation. On module side, let's continue this path. Module side for locals, you should consider locals as a constant to be honored or relied on. So let's take, for example, bucket name. Let's say we do have to create our own module for bucket creation for any reason that comes to mind or need. Then we can, for example, set bucket convention name. And then whenever someone uses this module, it means that they are bound to this convention name, which is good because naming convention. Because let's say I want to make sure that all buckets of my company are listed with company name, etc. So that way we can enforce standards that make sense to us. And basically, it is a constant to be honored or relied on. So this is one example. And also a quick note about this specific example. If you set anything about naming convention and stuff like that in Terraform, just remember that cloud providers have sometimes characters limitations, like for anything, for resources, naming, and stuff like that. So just have that in mind whenever you introduce anything related to naming convention in Terraform. On the live side, and when I say live, I mean where we call the model. So if we take, for example, the world of developers, they create a class, which is the model, and then live is the instantiation of the class. So live is where we call the models. How do you use variables there, or how should we use variables there? If used once, set a default. But if it's used per region, etc., then you should use tfvars, a file for each region or account or whatever. On the live side for locals, you should avoid using locals because we want to make sure that the live side is kept as generic and simple as much as possible and leave the logic to the model side. And also try to utilize data sources to pass outputs to the model. That way we have dynamic values being introduced to the models, and then we don't need to have any hard-coded code. We just have dynamic configuration already inputted to the models, which is a good practice to have. So to sum things up in regards to variables and locals, use tfvars where necessary. Another thing that I didn't mention before is utilize environment variables. This is basically variables that you have out of the box. So if you have environment variables, you can utilize them and save some new variables on the Terraform code. Use locals to the hardcode one-time names, decrease code repeatability, and try to keep things as generic as much as possible because we want to make sure that if we do create custom models, it's custom, but it's still generic enough for other people in the company or in the other departments to use it. And I will show example for it later. So keeping things as generic as possible, it's a good thing to have. Bad thing is to, for example, Terraform allows you to have multiple locals block. It's okay, but if you don't really need to do it, don't utilize too many blocks because then it will overburden your eyes. Maybe people will put it in different files. Then it will be hard to maintain in day-to-day. So if you don't really have to, use only one local block. Another thing in couple to that is decentralized vars. Don't put it in different files. People will have a hard time tracking them. Just have it in one file, and I will have a section about files structure in a bit. And ignoring environment variables, why do it? You know, we have environment variables that we can use and utilize and save new variables, so don't try to not to do it. And the ugly thing is to hard-code variables values where it is not necessary, because this is the meaning of variables. They need to vary, so you need to allow them. So if there is no really a need to hard-code values of variables, don't do that. File structure, so I mentioned it in a bit. Let's see how do we structure the files inside both models, custom models, or the live side. So we can take example from community models, Terraform AWS models, for example, or other models that are out there. This is the community standard. So we have main TF, which is the main logic that holds all the resources for the main logic, and then variables, data, and either versions or config. Config TF is like for where is the remote state block and providers block and stuff like that. So this is that. And then there are other files that basically represent what these files contain. So let's say I have a module that creates a VM. So the creation of the VM itself will be in main TF, but then if I need a load balancer for that VM, or I need security groups, then I'll create two separate files, load balancer and security groups, and then populate it with these things. And another thing that you should have in mind is to have sub or nested modules. So let's say you created a module of your own. If you can break it down to submodules, it's preferred. Why? Two main reasons. First of all, maybe you can reuse those submodules. For example, again, let's take a community as an example. The VPC module have a submodule of VPC endpoint, and then the EKS module have a submodule of node pools. So it's awesome because let's say I created an EKS cluster with the module of EKS, but then I only create it once, and then I want to create more node pools. For that, I only reuse the submodule of node pools, and that's that. So if you create custom modules that you see that you can break down to submodules that can be reused, then it's also a good practice to do. Another reason why to use submodules is that it allows you to break down variables, and then instead of one gigantic variable files that you don't know what is being used, what not, you have it break down to the submodules and the main logic of the module, and then it's much more easier to maintain it that way. This section I really, really like. Applying classic code best practices on Terraform. So I don't think that you or even me, nobody thinks that Terraform is a pure programming language. I'm not saying it is, it's not. But similar rules of writing code apply to Terraform as well. How do I know that? Because before version 0.13, you couldn't even loop over modules. And only after the release of that version, HashiCorp understood that, okay, we need to allow people to loop over modules. And then with a single module call, you can loop over modules after this version. So HashiCorp realized that they should introduce classic code best practices on Terraform as well. And this is why you should do it as well and go and apply it on your day-to-day. Which means keep your code in source control management, GitHub, Bitbucket, whatever out there. Keep the code as simple as possible. Do not repeat yourself. Even functional programming principles can be applied on Terraform. The code should always be idempotent. And in regards to human clean, I want to quote something from a great article I found online. I will have a reference slide later on. Article by Thyssen-Ur. He said, and I really couldn't agree more, that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate. If used correctly, it will get executed nevertheless. But since human beings are the ones to maintain this code, we need to make sure it is readable. So anything of the sort of refactoring and clean code and naming convention, etc., are invented so that we human beings can read the code better, not for the sake of computers, but for the sake of us human beings. So that's why we have code best practices that we should follow in order to be able to maintain the code in the day-to-day. After a year, after we leave and don't have our former colleagues get mad at us that, look at the state that you left your code. We want to make sure the code is in a readable and maintainable state. Long haul. This is the last section of this presentation. Long haul means things that you should consider and plan ahead when you work with Terraform. So a lot of times, other teams need to work on your same infrastructure, and they need audit, and they need visibility, or you need to isolate environments. Dev production, you need to address that. You need to scale Terraform usage based on teams. So I'm going to share a few practices here that will help with all of that in the long run. But beforehand, I want to ask you this question. How do you envision the infrastructure and the company's needs? And actually, it was discussed in other talks as well that the hype, okay? There is a hype. And we need to avoid a hype. And I'll share a recent story that I have from my current company. So we had this daily sync at work. And I'm currently in the data engineering group, which means that I maintain infrastructure for data tools. And one of them is Apache. It was called Presto, now it was changed to Trino, but something with data. So we deploy it for the developers, and currently it's deployed on auto-scaling groups machines, a fleet of machines. And then during the daily sync, one of my team members said, hey, let's deploy it on Kubernetes. I'm like, okay. And then all the other team members jumped, yeah, let's deploy to Kubernetes. Yeah, let's do it. We want to work with Kubernetes. Yeah, that's awesome. So I listened to this discussion, and between me and myself, I'm like, okay, I figured whether I should support this, what's going on there or not. So between me and myself, I'm like, okay, I want to deploy on Kubernetes because it's good for my career, because Kubernetes is highly adopted, and if I'll work with Kubernetes, and I already had experience with Kubernetes, but as you know, Kubernetes is very complex operation, and you can't never know enough. So I said, if I'll work with Kubernetes again, that's good because I'll be more attractive in the eyes of my future employer. And I'm like, okay, it's good for me. But at this point, I didn't say, yeah, let's deploy to Kubernetes. I said, wait, let's understand what does the application want? What does the application need? Does it really need this scale or not? Does Trino even support Kubernetes? Maybe not. Maybe we will go to the official documentation, they say, no, we are too stateful, even though you can run stateful applications on Kubernetes, but something in the application doesn't really allow you to run on Kubernetes, and then we will go on a goose chase to try something that doesn't really work, or we will make it work, but it doesn't really fit the use case. So a lot of things to consider before we jump the gun and say, yeah, let's move to Kubernetes. So that's the thing. That's what I want. I want to work with Kubernetes, but I'm currently working for a company. The company needs me to represent the company's and the application needs and not what I need. And as you can see, the slide says, how do you envision infrastructure and company needs and not how do you envision Hila's career? Okay, so that's exactly it. We need to think about what's good for the company, the application, and the infrastructure. So I hope that this little story helped you set the tone, not always go with the high, but think about what your application needs and work with it. So since we planned ahead, since we thought about what we need, first of all, we chose Terraform. We understood that this is a good thing for the entire company. And we started to think about it, and this decision was done before me, but I talked with people. And they said that we wanted to do something that will help Terraform be adapted in the entire company. So that's why they thought about the Terraform codebase and how to structure it. And you can structure the Terraform codebase in a lot of ways. And I'm going to share with you here how we structure the Terraform codebase, and how we still structure the Terraform codebase in Wix, and why did we choose to do that. Or they, because I wasn't working there yet. So team, project, cloud provider, account or environment, and region. How does it look like? This. So we have the modules, as the custom modules that we currently have and maintain. And then the live, where we call the modules, we have BI for team, Airflow for project, AWS for cloud provider, production or dev or anything of the sort for account or environment, and use ES1 for region. This is the structure that we have. All the teams in the entire company, and we have a lot of people and a lot of departments in the company, have the same structure, and we all use the same repository. Why did we choose to go with this structure? First of all, Terraform is a platform. So this allows us to onboard all teams to the same repository, which means that we have one standard for the entire company. Everyone utilizes it the same way. It's very easy to onboard new members, new teams, and that way infrastructure and team scaling is much more viable and much more easy because of that. In order to support that, we have code owners usage. So in GitHub, you can define code owners that defines who has permissions to which paths in the repository. And that way, we have teams autonomy, which means that every team can manage their own infrastructure. They don't need to wait for the entire platform team to approve their PRs. They can manage and approve their own PRs when it is in the teams, under the teams folder. They get out of the box custom models to use, and again, custom, but we apply classical best practices, which means that we try to make our models as generic as possible to be used in the entire company and not for a specific team. So they get out of the box custom models to use. And practice enforcement, all the tests and checks that I'm going to share with you here in this notion is being applied on the repository level. So out of the box, they get tests and checks to make sure that the code is in a high quality, tags are being introduced, and they check for tags whenever someone adds new code, etc. So that was one reason. Another reason is to have small state files. So I hope that you know Terraform creates dependency tree for all the resources in a certain state that it works with. And sometimes Terraform doesn't do a great job. Okay? It creates invalid dependencies. I had a time where I just change a tag, and then in the plan, it shows me that it's gonna destroy a resource. Why? I just changed a tag. What's going on? So that's exactly it. This happens, these invalid dependencies happen when we have big blast radius and big state files. So we avoided this big blast radius by introducing this code-based structure because of this. This is the code-based structure, and then the state file is kept in this level, US East 1 level, which means that state file is only for BI resources, Airflow resources for the BI team in AWS, production or dev, and US East 1. So very specific, very small. There's a very little chance to have invalid dependencies and big blast radius. We avoid that, and everyone is happy, and we don't have any stuff to be concerned of, in this level. Let's cover a bit about workspaces, again, in the open source or source available way, and not cloud or enterprise workspace in the open source. So when do we use it? When we have the same Terraform config for different customers, AWS accounts or GCP projects, for example, because workspaces isolate their state. So if you run Terraform plan, Terraform will not see any existing state of any other workspaces. It is isolated. So this example is very classic. So as you can see, I have the live code and models, which is the same thing, and then same code, and then for each customer, basically the code base is in isolated workspaces. Coupled with that, let's say we have customers in different projects, but there are also same service that needs to provide service to the customers, like login service or financial service or something like that. So this is also an example that can be introduced by workspace. Every service in different regions is in different workspaces. But some notes about workspaces that worthwhile mentioning. So first of all, you should really consider using Terraform wrapper when you use workspaces to avoid human errors. Because how do you use workspaces? With CLI, Terraform workspace select X. If I forgot to do the select, production incident. Okay? So try to avoid that. Don't go and change workspaces by yourself. Create a Terraform wrapper, like a Python wrapper that handles the workspaces changes for you, and that way you are safe. Another thing is that you have less visibility, because either if you haven't used in the code Terraform workspace conditional built-in variable, then you don't even know if you have workspaces or not. And if you do check, you do Terraform workspace list and you see workspaces, it doesn't mean that they are in use. So you have less visibility, so better do whatever you can in order to introduce more visibility if you choose workspaces. And another thing is that if you choose to use data remote state in your code to address other remote states, it's very complex, very problematic. So if it's something that you need, that you know that you will need, make sure that you either stay away from workspaces or address it in order to deal with it better. Some useful workspace usage that you do have, though, is whenever you want to test a set of changes before modifying the main production infrastructure, which is usually the default workspace. So let's say I can create a new workspace, do my changes, see that the syntax is okay, that whenever I apply, I get expected results, and then I apply it on the default workspace, and everything is okay. So this is like a classic usage. So to sum things up in terms of the structure in the Terraform codebase and the notion of planning ahead when you think about it, is that if you plan ahead and you think things through, then you're able to set up Terraform codebase in a way that allows small state files, which is very, very important whenever you work with Terraform. And you're allowed to have Terraform as a platform and then enable infrastructure and team scaling out of the box, because people can just onboard to it, and that's that. A bad thing, if you don't plan ahead, is that sometimes organizational changes would require you to restructure the code, which is not great, and we don't want to have changes spring up on us like that. We want to be prepared, so we want to avoid that. So this could happen if we don't plan ahead. And also, if we use workspaces for the wrong usage, then we could also potentially have a lot of issues. And the ugly thing, really, please, 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 and it's all tied to that. If you have huge state files, you will definitely have invalid dependencies, huge blast radius, and then it will be very hard to maintain Terraform in day-to-day, because you can't apply things. You need to start apply with a target flag. You can't come out of it. So try to avoid having huge state files really at all costs. Let's talk about Terraform execution. So you can run Terraform from your laptop, of course, but you need for that credentials, you need local configurations, and you don't have audit, which is not great. So that's why you should always have remote execution that allows you to have audit. You don't need these local credentials, etc. And you should also apply with a plan file. That way you know exactly what is being applied. This is something that Atlantis do. Let's mention Atlantis now. I usually mention it later, but let's do it here. So Atlantis is a pull request automation for Terraform, open source tool that you can utilize for your pull requests. So whenever you, once you integrate it, whenever I open a PR, I do Atlantis plan. I see the plan in the GitHub UI, and then I check the plan. If all looks good, I do Atlantis apply. Once I do Atlantis apply, two things happen. It gets applied and gets merged to master or main. And Atlantis do it with a plan file that it keeps aside. So let's say I opened the PR, forgot about it, didn't do anything, and then got back to it the next day. It will say, hey, your plan is expired. Please run a plan again, because maybe someone else ran something, right? Or also the thing that I mentioned before with the lock of the states. If I run a PR now, I try to apply it, but someone else tries, no, if they try to apply a PR that touches the same state file as me, and my PR opened first, then they will get a message that, hey, your state file is currently being locked by PRX. Please deal with that first, and then we will be able to merge your PR or apply your PR. So this is a good practice and good guardrails that Atlantis provide whenever working with Terraform. So I really encourage to incorporate Atlantis in your environment. Another thing is that you should really set up a Terraform timeout that makes sense to you, because in one of my usages, I had to create auto-scaling group that uses the spot instances. Like you should set a price for the instances. And I'm an Israeli, we like to not pay. So I set a very low bar, very small price for the instances. And then once I had to try to apply, then I waited and waited because the price wasn't right and no instances were available in that price. So I had it, at that time, I didn't have timeout. So I did Control-C. And of course, I didn't have backups. So my Terraform state got messed up, which is not good. So this also means, this is also a reason why you should avoid running and executing locally, because you have these guardrails in place whenever you do it remotely. And the ugly thing, as I mentioned, if you do execute locally and run Control-C, you could potentially mess up your state. And please, it happens to me when I just started out with Terraform. Maybe they changed the behavior until now or not. I don't want to find out. So just avoid that. Set up a timeout that makes sense, and then it will time out for you gracefully, and you don't need to wait. Last but not least, the thing that I build up for in this entire presentation, the practices enforcement. So basically, this means, again, tests that you can introduce to the Terraform codebase that will allow you to basically do anything that you want. You want to make sure people added tags, then you can add checks that if the maintainers didn't add tags to the resources, the PR will not merge. You want to make sure that, hey, if someone introduces resources that above $10,000, then it will alert the FinOps team. Anything that comes to mind, anything that you want, sky's the limit. You can introduce anything that makes sense to you. And these kind of things are being implemented also in community models. So in general, we need to check if the code is readable, like ideas what to incorporate in practice enforcement. Check if the code is readable, if the resources are tagged as mentioned, if it's reusable, if it's clean. And let's see example from the community model. So this is from a Terraform AWS model of auto-scaling. As you can see, there are checks here to check if the contributor formatted the code using Terraform FMT, if they added documentation, and also if the code is actually working using tflint. So this is like out-of-the-box things that you know that ran on the code if you choose to utilize the usage of this community model. But again, you should also apply practice enforcement on your custom models and on your Terraform code base in general. So you can do pre-merge linters and formatters and logical checks. You can have GitHub actions to run those tests before a PR is able to get merged or not, or to do it and incorporate it in CI pipeline checks. You can also have Slackbot drift reported that it tells you, hey, there's a drift between your current environment and your code, or you can utilize Atlantis, as I mentioned before, that basically prevent us the need to have this Slackbot, because then since it applies the code and merge it, then it means that main equals actual environment, so we always know that we are in line, no drifts, and that's great. So that's why Atlantis is also good in that as well. The bad and the ugly is actually if you don't have practice enforcement. So you would potentially face security issues and non-compliant configurations getting introduced to your environment. And on the right, I've put some open source enforcement and helpers. If you do want to embark on this journey of introducing practice enforcement, these tools are very good for that. InfraCost, we can also use it to detect the amount of cost that the resources have, and then send a message to FinOps team if it's too much. So these tools are very good to use for any practice enforcement that comes to mind. So I talked about a lot of things here, right? A lot of practices, but the most important ones are the ones that are written here. I hope that it's big enough. You tell me. If it's not, I will make it bigger next time. But these are the most important things that you will feel it in your day-to-day if you don't follow them. So code-based structure, if you do enable Terraform as a platform and small state files, it will help you enable infrastructure scaling and team scaling, and everyone can use it and have high quality code, and you don't have any issues in the day-to-day because your small state files are already there, and you know that invalid dependencies are very little to occur. And practice enforcement, both to enable infrastructure and team scaling, but really to do anything that comes to mind to make sure that people engage not only with Terraform, but with the cloud provider in a way that makes sense to you and with the guardrails that you want to set up. So, like any other tool, don't use Terraform in an ad hoc mindset. Plan for your future needs. And I want to quote something else from the Thyssen-Uhr article, very great article, don't worry, I have a reference slide right up. He said that programs evolve and code changes, and it's really uncommon for you to write a Terraform code and it stays the same. If it was the case, this is not how projects work, and if it was the case, I wouldn't even be here talking about Terraform with you, because everyone would just use it the same way, write it the same in the same methods, and that's it, continue with our lives, and that's it. But it's not how projects work. We want to make sure that we have projects, because what is a project? Moving from one current state to a desired state. This is a project. So in order to enable projects to happen and to allow our businesses to succeed, we need to introduce projects. And in order to introduce projects, we need to plan ahead, think things through, and really allow our company to move forward and do whatever is necessary. So these are the references that I mentioned before. Thyssen-Uhr's article is here. Anything about labeling are here as well. Some important workspaces documents that you should read if you choose to go down this path. And Superlinter is also some out-of-the-box tools that you can, checks that you can incorporate in your GitHub repository of Terraform that already checks some stuff. So there are Terraform specific things, and there's a GitHub action bundle that you can incorporate. Awesome tools, awesome checks to incorporate in your code base. That's it. Thank you very much. Thank you.
Thank you very much, Hila, for that excellent treasure chest of Terraform knowledge.
Thank you.
I think we can take time for some questions. Are there any questions from the audience?
maybe you need to, yeah, to the black,
all right.
yeah.
Hello, hello?
Yeah.
Yeah, okay. Thanks for the talk, it was very interesting. I have one question regarding your code base. How do you deal with module versioning when you have just one repo? And how do you manage those dependencies?
Yeah, so you mean for the custom models, right, in the code base? So we have, for every module that we create a version, like V1, V2, stuff like that. If it's a crucial thing that we want to introduce, we want everyone to use it, then we do the work and check who uses this module, and then inform them, work with them to incorporate and check this changes on their side. If it's not important and it's something that only I need and the others don't need, I will create a new version and use that and have proper documentation of how this version differs from the other version if it doesn't really, if it really diverges from it and not have backward compatibility for the other version as well. So that's mostly it, but usually we always strive to change the same version and have like guardrails to the change. So let's say I want to introduce a new variable, I will set a default of none because nobody is using it, and then only on my call to that module I will set the variable. So we will introduce the changes as generic as possible to not harm any other people, and if we can't do that, then we will create a new version and use that one.
Thanks.
Any other questions?
Here.
Thanks for the presentation. One question, you said modules and submodules inside those modules and so on. I have a feeling whenever I do that, I end up chaining variables from basically the root all the way into the third or fourth submodule. Is there any suggestion that you have about that?
So I mean, same variable should be used for both sub and the main, you mean?
Yeah, so basically you have some input that goes into the fourth submodule, and you need to pass it from 1 to 2, from 2 to 3, from 3 to 4, and it makes actually the variable files quite big.
So it depends. If it's something that is for the entire module, like for the main as well, I would set it as a local, then it will get inherited to all the submodules and just have it as one bulk to use. If not, if it's something that should be used like separately for the submodules as well, currently I only think about having one variable and maybe just have like a reference to it through a data source or of some sort. But let me think about it some more and maybe we'll talk after the break.
Thank you.
Sure.
There's one over there.
Opa. Looks like a fun game.
As well, thanks for the talk. I was wondering, how do you actually deal with getting up to date? So, for example, we provide Terraform and infrastructure as a code for our customers, and each and every customer has his own repo, and he initializes a provider there. And initially, you talked about pinning of providers and as well as Terraform core version and for modules as well.
Right.
So let's say you have something around 350 different customers which have their own repo and initialize their own provider, obviously, and talk to their own AWS account. How do you ensure that they update their provider and not always stay on, I don't know, what's on AWS currently, 4, whatever, 5 even, let's say 5.13 for a year. And then they have this huge breaking change which will come with the version 6 of AWS provider or whatever.
Right. So for me, I would move forward to a different version only in 2 cases, whether you introduce new features or new vulnerabilities fixes that I gain profit from, not profit, but I gain like, it's profit, I forgot the word. It makes sense, it's worthwhile to promote to a new version, or if the version is obsolete. Like, I hope that nobody uses anything before 1, because I think it's already like end of life. But these are the 2 main reasons for me to move to another version. If there's nothing that makes sense to move to another version, why do it? Just because everyone moves? You need to check the versions to see if there are security fixes or any features that you really need. If not, I don't really see the benefit of moving just for the sake of moving. If you say, hey, this version have a feature that we need or it benefits to you, then you can say, to that company that you are, the customer that you're dealing, this version benefits you because you need ABC, and then you have this priority for them to move it. Because if not, if you don't give them the priority, you don't give them the benefit of why doing that, why should they do that? You understand what I say? So for me, only if there are security fixes or a feature that you really need, I will move to another version, and if it's end of life. If not, I would stay because the syntax is known, the features are what I need, and that's basically it. It's hard to maintain 300 people, 300 customers, and in order to help them help you, you need to show them it's worthwhile, and in order to show them, you need to show them why, and because you need the features, it is end of life, and then we can't support you anymore. Show them why it hurts them.
Thanks.
There's one final question at the back.
I'll try.
Opa.
Perfect. Yes. Also, huge thanks from my side for the talk. It was very interesting. You explained that smaller stacks are always better than big stacks. And my question would be, does that imply that you're always working with micro stacks, so one stack per service, or are there other criteria how you slice stacks or how you decide how big a stack should be?
So as I showed in the example, we do it per project. So once we have projects, then it's already being sliced because there's only this amount of resources that you need per project. So that way, we always make sure it is being kept small because it's per project, per team, per region, and etc. So that way, it's always small, easier to track. Small state files are guaranteed. So yeah.
Okay, but you don't slice per resource or something like that, so micro
No.
stacks. Okay.
We actually, I didn't mention it here, but we actually, on the live side, we don't use resources at all. We always call modules. So that way, we are always bundled to a certain module, and that way, it's also logical to maintain it that way because you only have modules and not resources, and then whenever you see a resource, you don't know what it's related to this project, something else, only models, very capsulated, and it's easier to maintain it that way.
All right, many thanks.
I think we had one more question up front, which we can take.
Good luck.
Hello, check. Thank you very much for your great talk. It was very informative.
Thank you.
My question is, do you have any good best practice how to do your release management of your self-written modules?
So I would say it will be, again, as I mentioned before, we wouldn't progress towards a new version otherwise, only if it's worthwhile. So only if a new version, either a new version of Terraform that requires us to move to something else, or a new resource that we need to enhance on that module. So we need a very good reason in order to do this change. Once we have this good reason, then I will find the reasoning to convince other teams why they need it, and that's why I will change the version 1. Or they say, I know that it's only me that I need it because I'm in BI, and this resource is only related to BI workloads and not any other workloads. So that's why I will create a new version and then just add the relevant documentation. But it's all about reasoning and showing why you should do it. Because as we know, we all have projects, we have priorities for the projects. So if you want to convince people to maintain it, and as you know, versioning maintenance is not a product maintenance. If you want to maintain products of the company itself, like the main product, releasing versions is like the go-to. This is what they want to do. But maintaining versions of Terraform or custom models in Terraform, it's not in the priority. So if you want to make it a priority, check what the changes that you want to introduce, and then make sure that they see the worthwhile added. English is hard.
Added value.
Added value, thank you very much for that. And then that's the only way where you will gain like a buy-in for what you attempt to do.
Okay, thank you so much.
Cool. Thank you very much. Let's give Hila another round of applause.
Only if you want to. You don't have to. Thank you.